All right, guys, welcome to lesson 10. In this section, we're going to talk more about functions and the graphs. There's so many things that we can talk about when it comes to the graphs. So, informally speaking, a function increases over an open interval of its domain if the graph is rising from left to right. It decreases if it's going down from left to right, and it's constant if it is horizontal during that interval. Okay, so on number one, we're going to look at when is this graph increasing, decreasing, and constant. Okay, and we use the x values when we're finding this, and we always go from left to right. So from left to right, the graph is going down. It's going down right here. So it's decreasing from negative infinity to, and again, we're using the x values, so we get -2. And we always use parentheses here as well. All right, so again, we're going from left to right. All right, and then from the next interval is from -2 to +1, and here it's going up. So I got -2 to +1. And then it's constant from 1 to infinity. All right, so that's the idea. It's increasing, decreasing, or constant from left to right over certain intervals. Now, depending on the graph, it could always be decreasing, it could always be increasing, it could always be constant. All right, it doesn't. All three don't have to show up in the same graph. All right. Another thing that we can do is max and min. So if the graph goes on forever in either direction, then if it has like number 2 here, this graph is going on forever in both directions. But in this section in the middle here, it peaks and then it goes down, it bottoms out, and then it goes back up. So I have a max right here, and I have a min right here, and they're relative because it's not absolute, because the graph keeps going and will get higher and lower than these individual points. So this is x equals 3, and this is x equals -1. So I have a max at -1. And so I say f of -1, and I plug it in. So I got 2 times -1 cubed minus 6 times -1 squared minus 18 times -1 plus 7. And if I plug that in my calculator, I get a +17. And then I have a min at f of +3. So I got 2 times 3 cubed minus 6 times 3 squared minus 18 times 3 plus 7. And if I plug that into my calculator, I get -47. Okay, so here's what I got. I got a max here at -117. And I got a min here at 3, -47. Okay, nothing to it. All right. Another thing that we can talk about when it comes to graphs is symmetry. So if I can fold a graph over itself across the y-axis, let me rephrase. If I can fold a graph across the y-axis and fall back on itself, then it has y-axis symmetry. If I can fold a graph over the x-axis and it falls on itself, then that is x-axis symmetry. And then if I can fold it across the origin, you can think of it as one fold over the origin, or you can think of it as 2 folds, one over the x, one over the y, and then it falls back on itself. Then that is origin symmetry. You can also think of it as rotating 180 degrees. All right, so this first one is an example of y-axis symmetry. The second one is an example of x-axis symmetry, and then the last two are examples of origin symmetry. So we're going to spend some time on 3, 4, 5, 6, and 7 and test each one of these for a certain kind of symmetry. All right, and so here's what we got. So if I want to test x-axis or y-axis symmetry, I'm going to change. Notice that on y-axis symmetry, the only thing that changes is the x value. So I'm going to plug in -x and see what I get. So when I do that, the squared takes care of the negative, so I end up with my original back. And because I get my original back, then this is going to be y-axis symmetry. All right, now let's test for x-axis symmetry. On x-axis symmetry, the value that changes is the y. So I'm going to plug in negative y into my function and see if I get my original back. Well, I multiply everything by negative 1. I get y equals negative x squared minus 4. That is not my original. So this does not have x-axis symmetry. All right, what about origin symmetry? Well, in that situation, I'm going to plug in a negative y and a negative x and see what I get. All right, well, I get negative y equals x squared plus 4. Y equals negative x squared minus 4. So once again, this does not give me my original back. So I'm the only for this first one, number 3, the only one that is the only symmetry it has is y-axis symmetry. All right, let's do it again on number 4. All right, so I'm going to plug in negative x equals y squared minus 3. X equals negative y squared plus 3. That's not my original. That's not my original, so it does not have y-axis symmetry. All right, let's do x-axis symmetry. So x equals negative y all squared minus 3. X equals y squared minus 3. All right, that is my original. So this does have x-axis symmetry. All right, let's try origin symmetry. So I got negative x equals negative y all squared minus 3. All right, so I got, let's see, I got negative x equals y squared minus 3. X equals negative y squared plus 3. That's not my original. So the only symmetry it has is x-axis symmetry. All right, number 5. So plugging in negative x, I got negative x all squared plus y squared equals 16. Applying the squared, the negative falls out, and I'm left with my original. So this has y-axis symmetry. Checking for x-axis symmetry, I got x squared plus negative y all squared plus 16. Applying the function, I get x squared plus y squared plus 16, or this should be equal 16. All right, which is my original. All right, so this one also works. So it has x-axis symmetry and y-axis symmetry. Let's test both of them. X squared plus negative y squared equals 16. X squared plus y squared equals 16. This one also has origin symmetry. So x squared plus y squared equals 16. That's actually a circle. So if you knew that, you understand why it has all of the symmetry. All right, 2 more. Let's see, we got 2 times negative x plus y equals 4. Negative 2x plus y equals 4. That's not my original. So that doesn't work. You may also be able to tell that this equation right here is a line. And a line is only symmetrical if it goes to the origin. And it doesn't look like this one does. There's a good chance this one's not going to have any kind of symmetry. So let's just check it out though. So this is going to be 2x minus y equals 4. That's not my original. So there we go. No symmetry there. One more. So we got 2 times negative x plus negative y equals 4. So we got negative 2x minus y equals 4. And let's multiply by negative 2, or negative 1. So I got 2x plus y equals negative 4. So the left looks good, but the right doesn't. So this also does not have that kind of symmetry. So this one didn't have any symmetry at all. Okay, and then let's try 7. So we got y equals negative x all cubed. That's going to give me y equals negative x cubed. That's not my original. So this does not have that symmetry. All right, negative y equals x cubed. Y equals negative x cubed. That's not my original, so still no symmetry. Negative y equals negative x all cubed. So that gives me negative y equals negative x cubed. Y equals x cubed. That is my original. So I finally get some symmetry out of this. All right, so as you can see, it could have one of them, it could have all of them, it could have none of them. So, but you just got to test it out. Now, symmetry is one thing. Well, what if it's, but we can also determine whether it's an even function or odd function. All right, so the x-axis symmetry, the x is repeated. And we don't like that to be that's not a function. So we're going to exclude x symmetry from even and odd functions. So here's what we're dealing with. If I plug negative x into my original function and I get my original function back, that is an even function, which is it's an even function which has y-axis symmetry. If I plug in negative x and I get the negative version of my original function, that is an odd function, which has origin symmetry. Again, we're throwing out x-axis symmetry because the x-axis symmetry, the x's repeat, which is not a function. Okay, so here's what we do. I simply plug in negative x to the function and see what happens. So I got negative x, 8 times negative x to the fourth, minus 3 times negative x squared, plus 1. When I apply the function, the fourth is going to take care of the negative, the square is going to take care of the negative. So I got 8x to the fourth minus 3x squared plus 1, which is my original. So this tells me I plugged in negative f of x, or I plugged in negative x, and I got my original. So that means this function is even. Okay, let's do number 9. So I'm going to plug in negative x again. Let's see, I got 6 times negative x cubed minus 9 times negative x. All right, so that's going to give me negative 6x cubed plus 9x. That is not my original, okay, but all is not lost. So notice that it says if I plug in negative f of x and I get negative, if I plug in negative x and I get negative f of x, then it's odd. So it's definitely not even. We just found that out. So let me factor out a negative and see if I get my original back. So I get 6x cubed minus 9x on the inside once I factor out a negative. The inside, 6x cubed minus 9x, is my original. So in this case, I got negative f of x. So I plugged in negative x, and I got negative f of x. So this is odd. All right, so let's try this one. All right, I'm plugging in negative x. So I got 3 times negative x all squared plus 5 times negative x. Let's see, I got 3x squared minus f of x. That's not my original. Let's factor out a negative. I got negative 3x squared plus 5x. The inside of that parentheses is also not my original problem. So I plugged in negative f of x. It did not equal f of x. And it did not equal negative f of x. So this would be neither. Okay, so let's review. You plug in negative x. If the first thing you get is your original function, it's even. If you plug in negative x and it doesn't give you your original, but you can factor out a negative and get negative times the original, then it's odd. If you don't get the original and you don't get negative times the original, it's neither. Okay, now piecewise functions. All right, the graph to the right is an example of a piecewise function that follows this right here. So less than or equal to 1, it has one graph, and greater than 1, it has another graph. Also notice that because it says less than or equal to 1, the closed circle happens on the top graph, and the open circle happens on the bottom graph. Okay, So how do we use that with algebra? Well, on 11, it says -4. -4 is less than 0, so I'm going to plug it into the top function, plus 5. 0, all right, the bottom function says greater than or equal to 0, so I say 4 times 0 plus 7. And then 1 is greater than 0, so I got 4 times 1 plus 7. If you use your calculator, you see it's got -12 plus 5, that's going to be -7, 7, and then that's going to be 11. Okay? So that's what you get. On 12, it says that if it's between 0 and 15, the answer is just straight 40. So 10 is between 0 and 15, so my first answer is just 40. And then if it's greater than 15, then I plug it into the second equation. So 45 is bigger than 15, so I got 40 plus 0.60 times 45 minus 15. All right, if you plug that into your calculator, you get 58. All right. Now, in the previous section, we talked about difference quotients. I introduced them to you. But here, let's go a little deeper. So the average rate of change is a big concept as you get into higher level maths. And the difference quotient is the definition of, helps you understand the average rate of change. In fact, it's the definition of it, or it's one of the definitions of it. So you can, as you get into calculus, you no longer are trying to find slopes of lines, but you're trying to find slopes of curves. And of course, curves, the slope changes depending on which 2 points you're looking at. All right. And so the average rate of change, that's where that comes in. So between 2 points, which 2 points? All right. But if you remember from the previous section, you should know how to work these. So using the function notation, it says f of x plus h. And so the first thing I'm going to do is everywhere I see an x, I'm going to put it in x plus h. So I got x plus h all squared minus 4 times x plus h plus 7 minus f of x. So minus my original. X squared minus 4x plus 7 all over h. All right, so let's work on cleaning this up. All right, so if you know your special formulas for factoring, you know that x plus h all squared is going to give you x squared plus 2xh plus h squared. All right, distribute the -4, so it's going to be -4x minus 4h plus 7. Distribute the negative, you got minus x squared plus 4x minus 7 all over h. All right, see what we can get rid of. All right, let's see, I got a -4x and a positive 4x. I got a positive 7 and a -7. I got an x squared and a negative x squared. Everything that's left has an h in it. All right, so let's do h squared plus 2xh minus 4h all over h. Now, let's take a h out of the top. So I got h times h plus 2x minus 4 all over h. Okay, and so now I can get rid of that. And now my answer is going to be h plus 2x minus 4. All right, so the process is a little tedious, and you really need to be careful with adding and subtracting all that stuff in the numerator and making sure you set it up right. But once you do that, it's not that bad. All right, this one will be pretty straightforward. I got -4 times x plus h minus -4x all over h. All right, so I got -4x minus 4h plus 4x all over h. All right, I got a -4x and a positive 4x, and so this is going to be -4h over h. So I can get rid of the h's, and I'm left with -4. All right. 15, it's going to be like 13. It's a little more complicated. So I got 2 times x plus h all squared minus x plus h plus 3 minus my original 2x squared minus x plus 3 all over h. Okay, so 2, the inside of that's going to be x squared plus 2xh plus h squared minus x plus h, minus x minus h plus 3 minus 2x squared plus x minus 3. Now, I got to distribute that too, but there's already things I can get rid of. So I have a plus 3 and a minus 3, I have a plus x and a minus x. So I don't have to carry those through. So that would be 2x squared plus 4xh plus 2h squared minus h minus 2x squared all over h. Let's see what else I can get rid of. I got a 2x squared and a negative 2x squared. Everything else has an h and it's sticking around. So I got 2h squared plus 4xh minus h all over h. All right, let's factor out an h. So I got h times 2h plus 4x minus 1 all over h. The h's can cancel. And what's left is my answer. So I got 2h plus 4x minus 1 as my answer. All right, so that's a little, that's some practice using the difference quotient. All right, I hope you got something out of that. Reach out if you have any questions, and I'll see you in the next lesson.